Okay, I'm going to work through a few more problems from the review for the final, starting with number 18. This is a piecewise function, so we want to do it by 3 different table of values since there's 3 functions. So each one of these will be a function that we're going to graph on a small restricted domain. You use this information right here to pick your x values. So we would need to go from -2 to 1. Notice that even though this is not equal to, I do want to use it because it's our ending point. It will be an open circle. On this side there's an equal to, so this ending point will have a closed circle. You plug them into this. So -2 squared is 4 times another 2 would be 8. A -1 squared is 1 times 2 would be 2. 0 squared is 0 times 2 is 0. 1 squared is 1 times 2 is 2. I usually go ahead and just graph it as I go. So this is -2 and then up 1, 2, 3, 4, 5, 6, 7, 8. And that's an open circle. -1, +2, 0, 0, and 1, 2. That is going to be a closed circle. This is part of a parabola, so we'll draw that U shape. For my second function, I'm going from 1 to 3. And both endpoints are open, no equal to bars. We plug in 1 minus 3 would be -2. 2 minus 3 is -1, and 3 minus 3 is 0. So 1, -2 is open. 2, -1, 3, 0, which is also open. So this is part of a line that has a slope of 1. And the last piece is from 3 to infinity. So 3, 4, 5, that'll get us started. The endpoint is closed because of the equal to bar. And the answer will always be 4 because there is no x to plug in for. So 3, 4, and we stay at a height of 4 forever. So that is the graph of that piecewise function. Another one that I had a question about was number 19. It says express this quadratic into, this is called vertex form. To be able to do this, you have to complete the square. And the reason I know that is because I see this part right here, which is a binomial squared. That always happens from completing the square, essentially. So what we need to do is isolate the parts that have the x. From the part that doesn't. We're going to try to complete the square on this part, so we'll pull out a -3 because we have to have a 1 in front. This blank is just a placeholder. We would still have our -5 and our other blank. We would go ahead and complete the square by taking half of the middle term and squaring it. So that's 1 squared, which is going to be +1. Because this is happening on the left side or the right side of the equation, you have to do the opposite here, except it's not really a +1. It's a -3 times 1. So we actually did -3 times 1, which means we did -3. So if we want to do the opposite to keep this balanced, we need to do a +3. So this becomes f of x equals -3. This part factors nicely now in the middle, so this is x plus 1 squared minus 2. So that's the vertex form. And we need to write the vertex, which is opposite of this sign, so that'd be -1, and exactly the y sign. So this is my vertex. I want to graph this, so I'm going to plot that point first. And I would need another point on one side of it so that I can form symmetry. The easiest point is just to plug in 0 for all the x's. And notice that that just equals -5. So the point 0, -5 is on my graph. And because of symmetry, there's an identical point on the other side of the vertex, the same distance away. So there's the graph for that. For number 20, we are doing some function stuff. So we want to subtract the two functions. They're both fractions, so we're going to need a common denominator. I would multiply this fraction by the x plus 5 and this fraction by the x minus 4. That gives me, I have to distribute this, so this would be 2x squared. 2x times 5 is 10x. Negative x times x is negative x squared. Negative x times negative 4 is positive 4x over my x plus 5 and my x minus 4. I would combine like terms on the top, so this is x squared plus 14x over x plus 5, x minus 4. So that is the answer to the A part. Oops, sorry. For B part, you're doing division. So you stack F on top of G. You want to do this first because this shows you your domain, which is what we asked for in part D. So we would write this as 2x over x minus 4 times x plus 5 over x. The x's can cancel out, and so we get 2x plus 5 over x minus 4. Now that would be my answer to the B part, but we'll have to talk about domain when we get to part D. And then for C, we're doing composition, which is, remember, f of G, so you plug G into F. So for this one, we need to write F as a shell. So 2 blank over blank minus 4. Plug in the other function for all the blanks. And this has got a lot of little fractions, so to clear out those little fractions, I'm actually going to multiply everything on top and bottom by x plus 5. That's legal because you're doing it to both top and bottom of this big fraction. So that's going to cancel, and up top that'll also cancel. So we get 2x over x. This one will get distributed, so that would be minus 4x and minus 20. Computer's taking a minute. And minus 20. And then the final answer for C part then would be 2x over negative 3x minus 20. Part D says find the domain of all these. For the subtraction one, it's pretty basic. You just have to look at the denominators. So we can't be negative 5 or positive 4. For division, you have to be more careful. You actually have to look at anything that's a denominator originally, which means this and this are both in the denominator. And so is this. So, sorry, I was trying to highlight that, but it did not want to work. So we can't have positive 4 because of this. We can't have negative 5 because of this. We also can't have 0 because this is in the denominator of the big fraction. So my domain is going to be not negative 5, not 0, and not 4. So that's my domain on that one. For the last one over here, you have to do two things. For the domain of a composition, you find the domain of the interior part, the one you plugged in, which for this one, x can't be negative 5. And then you find the answer at the end. So we set negative 3x minus 20 equal to 0 to see what this problem is. So that would be negative 20 equals 3x. If we add the 3x over, negative 20 divided by 3. So the overall domain for this one would be, sorry, I'm writing sideways tonight, negative 20 over 3 is out. That's kind of out. Let me erase that and rewrite that part. So the domain is that we can't have negative 20 over 3 or negative 5. So different situations call for different domain restriction rules. Number 22, we're supposed to be doing quotient and remainder. Since this is x to the first power, I would do synthetic division. So first step is to solve that over. You write that in a box. You write all of your coefficients from the highest power down. Anything that's missing gets a 0. So this is a fifth power all the way down to a second power. So we need a 0 for the fourth power, a 0 for the third power, then the 6. We're missing x to the first power, so we need another 0, and then our 7. In synthetic division, you pull the first number down, and then you multiply. So this is negative 6. You add. You multiply. That would be positive 12. You add. You multiply. That would be negative 18. You multiply, that would be 36. You add, and then you multiply. And our final step is to add that last group, which would be, let's see, 72 minus 7. It's too late for me to do that in my head. 72 minus 7 is 65. I could have done that. So this is negative 65. Remember, your final answer is to write them with their actual variables. So the quotient would be 1 power less than this. So 3x to the fourth minus 6x to the third plus 12x squared minus 18x minus 36. And the remainder is just the negative 65. Another one I was asked was number 28. For number 28, you have a certain radioactive substance decays according to the formula A of T equals A sub 0 e to the negative 0.0072 T, where A sub 0 is your initial amount of substance, T is time and days, approximate the half-life. So it doesn't matter what you start out with. You could have 100 grams of something or 1,000 grams. In the end, this guy is always half of the original. So this is 1/2 of the original equals the original times this e to this power. So when you go to solve this, you'll divide the a sub 0 out. Essentially, it's always going to get divided out because you're taking this and just cutting the number in half. So we get 1/2 equals e to the negative 0.0072 t. Because your exponent is a variable, you're going to need a log to get it out of the exponent. Our typical one that we like to do is either log base 10 or natural log. Because this is an e, I'm actually going to use natural log. So we take a natural log of both sides. Then we can pull that power to the front because of our power rule for exponents. So this will be natural log of 1/2 equals negative 0.0072 t times natural log of just e, which by the way is a special log. This is e to the e, so this is 1. If you type it in on your calculator, you'll actually see that, but that guy is actually 1. So he's kind of just out. And then we would divide by this to get the t by itself. And I don't have my calculator as handy. I mean, I do, but if you type this in, you should get the decimal approximation that's in the answer key. My son is starting to wake up, so I'm going to have to hurry through this last one. Use the compound interest formula to determine how long it will take $1,000 to double if it is invested at 6.5% per year compounded quarterly. Quarterly means that you do your compounding 4 times a year. Your rate has to be written as a decimal. So 0.065. $1,000 is your principal or starting amount. They want it to double, so that means your ending value is 2,000. And this is not continuous compounding. So this is the regular old compounding formula, the one that has the n in it. So we put in our things that we know. 2,000 equals 1,000 times 1 plus 0.065 over 4. 4 again for n, and we don't know the number of years. So again, because this is a variable in the exponent, we're going to use a log. I would first divide the 1,000 over so that that equals 2. And then I don't care about natural log this time, or because there's no e base, I could just do log if I wanted. You could also do natural log. It really doesn't matter. Do log of all of this. Because then we can pull this power of 4t to the front. So we get log 2 equals 4t log of 1 plus 0.065 over 4. And we just need to leave the t over here, so we'll actually divide everything else to the other side. So you would want to take your calculator and divide log 2 by a 4 and a log to this parentheses. And I'm going to have to cut it off right here. I got to go check on my son. But you can type this in on your calculator and check it against the answer key for the review. So hopefully this helps some people get through a few more of the examples on the review problems.